Hello, I'm Oriana. Welcome back to part 2 of our Wi-Fi Aid episode. On our last episode, we managed to verify that our wireless connection issues are a product of users inputting the incorrect Wi-Fi password. This just leaves us with the remaining DHCP and DNS issues. So we go back to our Wi-Fi Aid page and check out our DHCP issues. A DHCP failure occurs when the AP receives a client request for an IP, but receives no offer from the DHCP server after 20 seconds. This DHCP issue seems more serious than our previous wireless connection issue. If we look at laptop 27, we see that this issue is especially serious. Just like before, let's check what events have occurred for laptop 27. Well, it doesn't seem that we're learning anything new. The Wi-Fi Aid logs are simply telling us that this client failed to receive an IP address. So why don't we check out what other event types are on the list? For now, let's try adding DHCP server events on our list. Well, I think we just found our problem. It seems that the DHCP pool from our cloud-managed firewall has been exhausted. Although this may look like a rookie mistake, this type of issue is actually becoming more and more common. Modern handheld devices have started the trend of using randomized MAC addresses whenever accessing a wireless network. This design is aimed at protecting end-user privacy. However, this creates inconveniences to corporate or enterprise networks that implement strict network policies. Such is the case with our DHCP pool. DHCP is designed to allocate an IP address based on every unique client MAC address. If our client uses a different MAC address every time it reconnects, it makes sense that we can run out of dynamic addresses very quickly. In cases like these, we can either increase the DHCP pool size, change into a larger LAN subnet mask, or decrease our lease time. For the time being, we're going to decrease the DHCP lease time since this has the least impact to our live network. So we can now cross off DHCP issues from the list as well. We're now just left with our DNS issues. A DNS failure occurs when the AP does not detect a DNS result from the server for 15 seconds after the client sends the DNS query. Laptop 8 seems to show the most number of DNS failures. We can click on its failure count to filter and check these related event logs. We can see that this client has failed due to DNS timeout when connected under different APs. But hold on. It seems that all these 6 failures have occurred while connected under the guest SSID. We just might be onto something here. Let's go back to our Wi-Fi Aid and, this time, focus on the status of our guest SSID. Just like with the client list, we can click on the failure count of the SSID to only display failure events related to this SSID only. It looks like this SSID has encountered nothing but DNS failures. I think we can conclude that the DNS issue is only occurring in the Zyxel network's guest SSID. We can verify that the guest network happens to be using VLAN 200 subnet by tracing the SSID and firewall interface settings. By inspecting specific policies that involves the VLAN 200 subnet, we eventually find that we do have a policy route assigned to this subnet. With this policy route, we now know that traffic from the guest Wi-Fi is only directed towards the service provider network. The firewall also has a second policy route that directs LAN 1 traffic to the remote network. But I couldn't find any DNS issues on clients connected under LAN 1. This makes a strong case that the issue must be coming from the service provider network. From here, we will need to consult our service provider to find out what is causing the client issue. And that's a wrap. I'll have to report back to Janice and have her check whether there has been noticeable improvements on the Wi-Fi. Thank you for joining the journey through Wi-Fi analysis. Like, comment, and subscribe. And I hope to see you in our next episode.
We're Zyxel, and we're your networking ally.